Hi, good morning, dear students. Hi. In the previous class, we learned about in the presence of electric field how magnetic field is produced, and in the presence of magnetic field how electric field is produced. Now, in this class, we are going to learn about the electric motor and electric generator. So, first one, motor. So, electric motor. So, how it works and what is the principle involved in this? Okay, we are going to learn in this class. So, electric motor means, so with the help of electric energy, it produces magnetic effect. With the help of electric energy, it produces magnetic effect. That is the main principle in electric motor. Okay, the main principle involved in electric motor is it produces mechanical work. So that means either rotation or movement. So that is with the help of the electricity. So that open page number 136. They give the some important things about electric motor. So electric motor is a rotating device that converts electric energy into mechanical energy. Underline that. That is very very important and the principle involved in that. Okay. Electric motor means it converts electrical energy into mechanical energy. Okay. So that is the main point. The next one, the electric motors is used in electric fans, a refrigerator, mixers, washing machine, computer, MP3 players. Okay, in all this we are using electricity and we are converting that into mechanical motion. Okay, that's why this is the main principle involved in this, and the device which uses the electric motor principle or the device which uses electricity and it converts into mechanical energy, the refrigerator, electric fans, mixers, washing machine, computer, MP3 players. Now we'll see how electric motor works. So here they give a small diagram about electric motor. So the main parts here is the magnetic bars. So here they consider north and south pole, then armature and axle, then brushes and battery and key. So roughly I will draw one small diagram. So this is, I will consider this as north pole and armature. Armature means it is a rectangular shaped coil in which a plenty number of coils are wounded in it. So therefore, and that armature is present between two permanent magnets. Okay, so here N and S are the two of permanent magnet, and this is armature. I will give the name as A, B, C and D. And then here one axle is present. So this is for attachment of the split ring that comes later. So here split rings. A single ring is divided into two parts. Okay. And similarly on this side. These are the two split rings present on this. So that means okay, it is around the axle, and I will give the name as P and Q. P and Q are the names given for the split rings. Okay, split rings. Split rings. Then for the split rings, two brushes are connected. So and Y. X and Y are the names for the brushes, and the armature is connected to this brush, and armature is connected to this brush, and then these are connected to a battery. So one side battery, positive, negative, positive, negative, positive, negative, then one key. So this is battery and this is key. Okay, just look at the figure. Okay, so this is positive, negative, positive, negative, positive, negative. So now we'll learn how this electric motor works. The description or working is given in your textbook. I'll just explain this. ABCD is a coil, and then N and S are two powerful magnets, and between these two powerful magnets, the ABCD, that is called as armature, is present, and this armature is present perpendicular to magnet N and S. Okay, that is present perpendicular to the magnet of poles north and south, and the ends of the armature are connected to brushes and split rings. Okay, P and Q are known as here split rings, and X and Y are the brushes. Okay, so brushes are fixed, and this P and Q are split rings, and that is wounded, and inner side of that split rings are insulated, and then these brushes are connected to battery and plug. So here, as I told you that the working of motor is it converts electrical energy into mechanical energy. It converts electrical energy into mechanical energy. So for example, in the first case, so here two cases arises. In the first case, the electrical energy passes through this battery. So when electricity passes through this, it will pass to P, and then it goes in the direction A, B, C, D, and then it comes to Q, and then finally it reaches the other end. So as I told you that A, B, C, D, the armature is perpendicular to these two magnets. So that's why, so here when electricity passes through it, the AB, arm AB moves downward. Arm AB moves downward, and arm CD. So arm is one side, okay, and arm CD, it moves upward. So the first case, arm AB moves downward and arm CD moves upward. So here electricity passes through ABCD's direction. Okay, this is another one important thing. The electricity passes through ABCD direction. Okay, when electricity passes through this, the first arm, that is arm AB, moves downward and arm CD moves upward, and the current flows in ABCD direction. And in the next half, so that means here the ABCD moves upward and the AB moves downward. That means the first half rotation is in anti-clockwise direction. Rotation is in anti-clockwise direction. And then in the second half, again electricity passes. When electricity passes, these two split rings P and Q, they will change their position. So initially, so this is initially P is connected to X, P to X, and Q to Y. This is initial case. And in the second half, the split rings P and Q change their position, and what happens? Finally P is connected to Y and Q is connected to X. So initially P is connected to X and Q is connected to Y, and in the second half P is connected to Y and Q is connected to X. They will interchange their position. So in the second half again current flows, and now it moves from here. Now in the second place it is Q and here it is P. In the second half, RAB moves upward. RAB moves upward and RCD moves down. RCD moves down. So in the initial case, RAB moves downward and RCD moves upward. In the second case, RAB moves upward and RCD moves down. Now in this case, again, due to the interchange of the position of the split rings, the current again flows in ABCD direction. The current again flows in ABCD direction. So now main working of this commutator or split rings is it interchange the direction of the current. It interchange the direction of the current. So first half the armature moves in anti-clockwise direction and the second half the armature moves in clockwise direction. And in the last they gave one important thing. The commercial motors use, that is present in page number 127, an electromagnet in the place of permanent magnet. So here we use permanent magnets. The two poles of the magnets, one is north pole and another is south pole. But in commercial field, instead of permanent magnet, they are using electromagnet. And second point, large number of turns of the conducting wire in the current carrying coil. So in the armature, they are using large number of coils because as we know that if the number of coils are increases, then production of electricity also increases as well as its strength becomes greater. And the third one, a soft iron core on which the coil is wound. Okay, the coil, inside of the coil, the soft iron is used. Okay, so these are the main important things which used in commercial motors. So the main principle, so just comment me what is the main principle involved in electric motor. What is the principle? So option A, it converts electrical energy into mechanical energy, and option B, it converts mechanical energy into electrical energy. Comment your answer fast. So comment your answers fast. It converts mechanical energy into electrical energy, or it converts electrical energy into mechanical energy. Fast. So what is the principle involved in motor? Option A, it converts electrical energy into mechanical energy. Option B, it converts mechanical energy into electrical energy. First, then another thing. So as I told you that, so in the first case AB moves downward and CD moves upward, and in the second case I told you that AB moves upward and CD moves downward. So here the direction of the current or the movement of the R is governed, or that is found with the help of Fleming's left hand rule. Okay, that is Fleming's left hand rule. In the previous class we learned about Fleming's right hand rule. So according to Fleming's right hand rule, when we put first three fingers of a right hand mutually perpendicular to each other, then the forefinger shows direction of the magnetic field and thumb represents the direction of the motion of the conductor, then the middle finger shows the direction of the induced current. Induced current. Okay. So according to Fleming's right hand rule. So here we are not using Fleming's right hand rule, here we are using Fleming's left hand rule. In the previous class we learned about Fleming's right hand rule. According to Fleming's right hand rule, it states that when we hold first three fingers of our right hand mutually perpendicular to each other, then forefinger represents the direction of the magnetic field and thumb represents the direction of the electric current and the middle finger shows the direction of the induced current. Now in this case we are going to learn, or we are using the Fleming's left hand rule. In Fleming's left hand rule, when we hold first three fingers of our left hand mutually perpendicular to each other. In this case also, the first thing is common. So in Fleming's right hand as well as in Fleming's left hand, we have to arrange first three fingers in perpendicular manner. Okay. So therefore, according to Fleming's left hand rule, when we hold first three fingers of our left hand mutually perpendicular to each other, okay, up to this saying. The next one, so in the Fleming's right hand rule, forefinger use the direction of the magnetic field and thumb, okay, I'll drop this. So we have to just remember what is the difference between Fleming's left hand as well as right hand rule. In right hand rule, thumb represents dash. Comment your answer first. So thumb represents dash, and the next one forefinger represents dash. Comment your answer, and middle finger. Okay, comment your answers. Then left hand rule. Again thumb, then forefinger, and then middle finger. So now comment your answers. In Fleming's right hand rule, thumb represents dash, and then forefinger represents dash, and middle finger represent dash. So don't comment only motion or magnetic field. Just write which finger shows which. So Akash commented as thumb represent current. That is wrong answer. Okay, thumb represent direction of motion of the conductor. Okay, thumb represent direction of motion of the conductor. See here, in Fleming's right hand rule, we have to arrange first three fingers perpendicular to each other, and then thumb represent direction of motion of the conductor, and then forefinger shows magnetic field. And middle finger shows induced current. Okay, these are the representation. Now similarly left hand rule. So thumb represent direction of motion of the conductor. Then forefinger represent magnetic field. Okay, forefinger represent magnetic field. Then middle finger represent current. Middle finger represent current. So the representation of these rings are same for the three fingers, but the arrangement is different. The arrangement of the fingers. So which finger we have to consider first, which finger we have to consider second, and which finger we have to consider third. That is very very important in this case, because that gives the meaning of the Fleming's rule. So in Fleming's right hand rule, first we are using forefinger, and in Fleming's left hand rule, first we are using forefinger. Then in the Fleming's right hand rule, second one we are using thumb, and Fleming's left hand rule we are using middle finger as second. Then in the Fleming's right hand rule, middle fingers as third place, and Fleming's left hand rule, thumb is having the third place. Okay, now, so all the fingers are same, only left and right hands are different, and all the three fingers represent same thing, only the arrangement is different. So therefore, according to Fleming's right hand rule, it states that when you hold first three fingers of a right hand mutually perpendicular to each other, then forefinger represent direction of the magnetic field, then thumb represent direction of motion of the conductor, then the middle finger represent direction of the induced current. And similarly, when it comes to Fleming's left hand rule, when we hold first three fingers of our left hand mutually perpendicular to each other, then forefinger represent direction of the magnetic field, and middle finger shows the direction of the current. So don't write here induced current, directly current. Okay. So based on this current and magnetic field, we are finding the direction of the motion. So that's why. So thumb represent having third place. So forefinger represents direction of the magnetic field, and the middle finger shows the direction of the current, and then the thumb represents direction of motion of the conductor. This is about Fleming's left as well as right hand. Okay, first one we have to use forefinger. In this case also we have used forefinger. Okay, in the first place. In the second place we have to use your thumb. Here we have to use middle finger. And in the third case, here we have to use middle finger, and here we have to use thumb. Okay, this is the difference between Fleming's left and right hand. How many of you understood these rules? Comment your names fast. So Fleming's left and right hand. How many of you understood? Comment your name fast. And here the working of motor, or the principle of motor, is it converts, or the device which uses the principle in that it converts electrical energy into mechanical motion. Electrical energy into mechanical motion, that is known as here the main principle involved in electric motor. So motor means if you consider a fan, then when you switch on the light, so electricity passes through the wires and it reaches the fan, and fan starts rotating. Okay. So when we switch on the light, the electricity passes through the fan and fan starts rotating. So rotating means it is mechanical energy or mechanical motion. So that's why we are converting it as mechanical energy. So electricity passes through it and it is converted into mechanical energy. So therefore it converts electrical energy into mechanical energy. So that is the main principle involved in electric motor. Okay, this will ask for 1 mark. That means the principle involved in motor. And the diagram of electric motor, that is for 3 marks. And sometimes they will ask the working of electric motor. And in that, one important thing is what is the use of commutator. So use of commutator is it changes the direction of the current. It changes the direction of the current. And another thing, so in electric motor we are using split rings. Okay, we are using split rings. And these two laws are very important, that is Fleming's right and left hand rule. Okay, thank you everyone. I'll continue in the next class.